Okay, so here's now the third installment of the final exam packet. As I mentioned in class, I think earlier this week or last week, um, ignore number 14. Nothing like that will be on the final. Ignore number 15. Nothing like that will be on the final. And ignore number 16. Nothing like that will be on the final. Let's move on to 17. Derive the quadratic formula. We've done this several times, but it might help to kind of see it again. So, always start with this. 0 equals ax squared plus bx plus c. I actually will tell you where to start with this one. Start with that. Then what you want to do, and actually, I like to put 0 on the right side. So isolate the quadratic in linear terms. Divide by a. This is kind of the tricky part. Take half of your linear coefficient and square it, so you get b squared over 4a squared. And then add that to both sides. So we want to be careful about that. Some of you would accidentally take half of BA or B over A times X. X is not part of this, right? You got to take the coefficient, which is B over A. So we add it to both sides. Okay. The whole point of adding b squared 4a squared is to make the left side per square trinomial that can be factored, like I just did right there. And in here, we multiply 4a, 4a, so you get b squared minus 4ac all over 4a squared. So x plus b over 2a equals plus or minus, so squaring both sides, square b squared minus 4ac all over 2a. Then move that over. And combine the fractions. So that's what we do there. 18. You will have to be able to sketch a quadratic equation and be able to know how to solve by completing the square. We'll start with the sketch. Remember, x equals negative b over 2a. That's to find the x coordinate of vertex. So negative negative 4 over 2 times 2, which is 1. To find the y coordinate of the vertex, you get 1, so 1 comma 1. Quick table. Let's plug in 0 and 2. You should get 3 and 3. Smiley face. And if you ask to find axis symmetry, that'd be x equals 1. Vertex, again, we know is 1, 1. To solve by completing the square, just like we did for quad form, isolate the quadratic in linear terms. We have negative 3 on this side. Divide by the leading coefficient, which is 2. Take half of the linear coefficient, which is negative 2, square it, so 1 and 1. You can factor the left side now, like that. Clean up the right side, then square roots. Now if you think about the square root of negative half, you can pull out an I, because you're squaring negative 1. And you can square both top and bottom separately, which becomes that, right? Rationalize. So it becomes I times root 2 over 2. So x will equal 1 plus or minus root 2 over 2, I. And you always want to put I at the end, so you have it in standard form. which now leads me to the next one, standard form. Um, try to say as nice as I can. I was a little bit disappointed that maybe you guys forgot what standard form is. But it could be the fact that you guys have a lot on your plate, but you gotta remember what standard form is. Standard form is A plus BI. Okay? I may even ask you that on the final exam. So if I say what is standard form, it's just A plus BI. A is the real number, BI is the imaginary number. Where you can think of B as like the coefficient for I. Well, clearly what I see right here, 10 plus 4i minus 3 minus 2i over 6 minus 7 times 1 minus 2i, that's not in standard form. We need to simplify it so that it's just a real number plus imaginary number, and that's it. So we clean it up. And the way you clean up is the way you would do anything normally algebraic. Combine like terms, FOIL. So you get 7 plus 6i up top. Down below, if you FOIL, you should get 6 minus 12i minus 7i plus 14i squared, which is 7 plus 6i over negative 8 minus 19i. I think maybe you need to get to that point, which is good, but then you're stuck, because again, you're not sure what to do. But again, if you understand what standard form means, we need to get them to look like A plus BI. That's not A plus BI. We have A plus BI over A plus BI. We got two complex numbers to be divided, but we got to simplify it as one complex number. The way to do that is multiply by its complex conjugate. So you change the imaginary number part. The reason why we do that is so that the imaginary number will just go away when we FOIL the bottom. But it won't go up top, but that's okay. So with the bottom, we need to get rid of I. Because if I's gone to the bottom, then we can finally get this into standard form. Negative 56 plus 133i minus 48i plus 114i squared all over 64 plus 361. When you do the outside and inside terms for the denominator, obviously they'll cancel, so I don't have to worry about I there anymore. So you should get negative 170, because 114i squared is negative 114, because I squared is negative 1, plus 85i over 425. I promise you the numbers will be a lot nicer on the final exam. I'll show you that. But if you factor in 85 from the top, and then we could see that 85 divided by 425, if you had a calculator with you, it's pretty obvious, but if not, you can try working out it's 5. But again, numbers will be easier than the real thing. Don't leave your answer like this. Separate it out. And it's got to be 1/5 times I, not I over 5, because A plus BI. See how that's A? See how that's B? Now it's a standard form. Okay, number 20. Then I'll stop this video again. Write a quadratic equation in intercept form. This vertex at 1, 18 pass through 0, 16. So we actually saw this kind of problem in the Jeopardy game, which many of you were kind of unsure about. So I think it's good that you have a chance to see this. So here's the process. Start with vertex form, because you're given the vertex. Convert to standard form. And then convert to intercept form. But still, you gotta know what the forms are, and you have to know the algebra that's involved in doing this conversion. But vertex form, if you know what that is, you're already on the right step. Vertex form is this, and you see 5 letters here, right? You see an X, a Y, an H, a K, and an A. Well, I already know H and K. So that's half the battle. And I can use this for x and y to solve for a. And by the way, don't assume a is like slope. This is not. There's no lines here. You can do it for absolute value. You cannot do it for quadratic equations. Even though you could use the concept of slope and get the right a value here, I could design the problem where it won't work that way. So don't assume that it's like slope. Plug in, solve for a. A is -2. So here's our equation now. Y equals -2 x minus 1 squared plus 18. Now we want to convert to standard form. Now standard form is y equals ax squared plus bx plus c. So it probably makes sense to FOIL, distribute -2 and add the 18, which I'll do right now. So it's just algebra, that's all I'm doing. FOILed, distributed, and I see there's two constant terms I can combine. So we can call this like step 1, step 2, step 3. All that was step 1. All that was step 2. And finally, step 3. So you can factor. Pull out a -2. Continue factoring it, and this will be intercept form because it's factored. It's called intercept form because I can, if I let y be 0, I see that x has to be 4 -2, which would represent the x-intercepts, because the x-intercepts when y is 0. And that's my answer. Okay, so let me pause again, and I'll do another video for 21 through 24.